Yes. So in this question, that is a man whose mass is 55 kg jumps vertically in air from sitting position in which his center of mass is 40 centimeter. This is 40 centimeter center of mass above the ground. When his feet are just about to leave the ground, his center of mass is 90 centimeter above the ground, and finally rise to 120 centimeter when jump as top. So what is the average upward force exerted by ground? जब वो jump कर रहा है तो ground उसके ऊपर force लगाएगा, and then what is the maximum speed attended by him? तो वो कितना maximum speed attend करेगा? तो देखिए 3 केस हो रहा है. एक तो ये केस सिटिंग पोस्टर का है, फिर ये उसका स्टैंडिंग में है, and then he jumps to टॉप पे पहुंचने पर, दिस इज योर टॉप पोजीशन, और टॉप पोजीशन पर जो सेंटर ऑफ मास है इस पे ये 90 सेंटीमीटर हो रहा है, और हियर इट इज 120 सेंटीमीटर. दिस इज द सेंटर ऑफ मास. तो इस चीज को, इस एक्शन को हम यदि इंडिकेटर डायग्राम में बनाएं तो ये सेंटर ऑफ मास का 3 पोजीशन हो गया. दिस इज ऑल सेंटर ऑफ मास एट द पॉइंट. हियर इट इज 40, दिस इज 90 एंड दिस इज 120 सेंटीमीटर. 3 पोजीशंस के. एंड this can be assumed as the height. This can be assumed as height. मान लीजिए ये h1 है सेंटर ऑफ मास का, ये h2 है और ये h3 है. कहाँ से? दिस इज द ग्राउंड. ये ग्राउंड लेवल है. तो ग्राउंड लेवल से ये अलग अलग सेंटर ऑफ मास हो गया इस पार्ट के. तो हमको अर्थ के द्वारा जो फोर्स लग रहा है वो प्लस जो हमको वेलोसिटी मिल रहा है, ये 2 चीज का कैलकुलेशन करना है. सो यू सी द वर्क डन क्या होता है? W इज इक्वल टू फोर्स इंटू डिस्प्लेसमेंट. फोर्स इंटू डिस्प्लेसमेंट. सो फोर्स इंटू डिस्प्लेसमेंट ये हो गया वर्क डन. एंड एनर्जी इज इक्वल टू E is equal to 1/2 mv square, that is the velocity. So during jump, this 1/2 mv square, that is the velocity given, is equal to f into the displacement, that is displacement h3 minus h2. ये इतनी एनर्जी दिया कि वो इस पॉइंट से हाइट जो 120 है पर पहुंच गया सेंटर ऑफ मास फ्रॉम 90. तो F is weight is equal to mass into acceleration due to gravity, and this is h3 minus h2. So what will be the velocity from this equation? This mass is cancelled. This mass is cancelled in both sides. Or velocity V is equal to under root of 2g h3 minus h2. h3 minus h2. So substituting value 2 into 9.8 meter per second square and 120 minus 90. 120 minus 90. So you find this one is 24.5 meter per second. This is the 24.5 meter per second is the velocity that is acquired. Hence, if H2 minus H1 is equal to mg H3 minus H2. The force exerted by the ground. This is nothing but force exerted by ground. So this F is, this F is mg H3 minus H2 upon H2 minus H1. H2 minus H1. So substituting the value 55 kg into 9.8, 120 minus 90, and divided by, this is 90 minus 40. 90 minus 40. So this value is 330 Newton F. So this value is amount of force exerted by the ground. So the answer of this is, first answer is ground force. Ground force is 330 Newton on center of mass. And the second, the velocity acquired V is 24.5 meter per second. 24.5 meter per second. So this one is the problem that is related to the muscles and human body. The next problem is, you see, the next problem is a velocity distribution for a flow over a plate is given by UZ is equal to 4Z minus 3Z square above the plate. Determine the velocity gradient and shear stress at the boundary and 3 meters above the plate. 3 meters above the plate. The coefficient of viscosity is given, that is 0.0 6 Newton second upon meter square. So solution is there is a plate. This is your plate which is fixed, and on this plate liquid is flowing like this, and the velocity is given as Vz is 4z minus 3z square. This is the velocity. So the velocity gradient is dv by dz. The velocity gradient is dv by dz is equal to, so we have to differentiate this equation. So 4z is 4 minus 3z square. So 3 into 2z. 3 into 2z. So this is 4 minus 6z. This is the velocity gradient. Now we have to find out the velocity gradient at the boundary and 3 meter above. So case 1, when z is equal to 0, that is at the boundary. At the boundary. Boundary means, yeah, this one is a boundary. Boundary is interface. So when z is equal to 0, the velocity gradient Vz by z is 4 minus 6 into 0. That is 4. This is your 4. And at 3 meter, case 2, when z is 3 meter, that is above 3 meter, तो 3 meter का मतलब क्या हुआ कि ये कोई z है हाइट जो 3 मीटर के बराबर कह रहे हैं. तो वेलोसिटी ग्रेडियंट क्या होगा? dv by dz is, this is 4 minus 6 into 3. That is 4 minus 18. That is minus 14. This is minus 14. This, the unit will be, what is the unit? Per second. It is per second. So this is minus 14 per second. Per second. Now we have to find out the shear stress. Shear stress on the shear stress, that is, this is eta into dv by dz. Eta dv by dz. So this value is given, it is 0.6, and dv by dz at boundary, this is 3, so this is 2.3. This is 2.3 Newton per meter square. That is the shear stress on the surface. Now next,
3 की जगह पे 4 रहेगा. सर वो 3 के dv by dz के 3 की जगह पे 4 रहेगा.
3 की जगह पे 4 आएगा. Okay. That is at z is equal to 4 minus 3z. So z is 0, it is 4. Correct. So it is It is 4. 4 into 0.6 is 2.4 Newton per meter. That is your answer. Next example is a Newtonian fluid. A Newtonian fluid acting on viscosity of eta is 0.42 Newton second upon meter square, and specific gravity Sg is 0.82, flow through a tube of diameter d is 20 millimeter with velocity 1.8 meter per second. Determine the value of Reynolds constant. Reynolds constant या number, you can say number, when density solution the density of fluid is equal to specific gravity into density of water at 4 degrees centigrade. This is the definition. So density of fluid, rho fluid, is equal to specific gravity is 0.82 and the density of the water at 4 degrees centigrade is 1000 kg, 1000 kilogram per meter cube, या 1 gram per cc. So this is equal to 820 kg per meter cube. This is the density. The Reynolds number is expressed as this is your K. K is equal to rho V D upon eta. So rho is 820, velocity is 1.8, and this is 20 into 10 to the power minus 3. That is 20 millimeter diameter, and this is 0.42. 0.42 is the viscosity, coefficient of viscosity. So this value, if you solve, then it is 41. This value is 41. So what you find, this K is less than 1000. K is less than 1000. So this implies that the flow is streamline flow. Streamline flow. This is your answer. To determine the value of Reynolds number, so this is the value of Reynolds number that we have find out. Now, next example is find the viscosity of glycerine this is 1.3 gram per cc is the density. If a steel ball of 2 millimeter radius with the density of steel is 8 gram per cc requires a terminal velocity of 4 centimeter per second in falling free in tank. So what we given, there is a tank in which there is a glycerine filled, and in this glycerine a ball is dropped, and this has the terminal velocity. So the basis of terminal velocity, the expression for the terminal velocity Vt is equal to 2 to the 2 by 9 r square eta. This is sigma minus rho into g. And from this expression, we can derive eta coefficient of viscosity is 2 by 9 r square upon Vt. This is sigma by rho into g. So this value, substituting 2 by 9 r square is 0.2 ka whole square. This is 2 mm, so 0.2 centimeter. And Vt is 4, terminal velocity is 4 centimeter per second, this value, into this is 8 minus 1.3 into 980. So this one is the expression, and by solving, we will get 14.6 twice. This is your eta. That is the coefficient of viscosity of the liquid. So these are examples, and other example can have the related to Poiseuille law. Poiseuille law say if Q quantity of water flow per second through a capillary tube of radius r and length L and length L, the same tube of length L and radius r/2 is connected, then the ratio of water flow will be given or find out. So solution, this is a tube, length L, radius R. It is connected with another tube of length R, radius r/2. Then Q is the amount of liquid. This amount of liquid is P pi r to the power 4 upon 8 eta L here. And this amount is Q dash is P pi r ke power 4 8 eta L r dash. This is r dash. So Q by Q dash is equal to P pi r to the power 4 8 eta L, and here it is P pi r dash ke power 4 8 eta L. So this cancel, here it is the cancel. The value is r to the power 4 upon r dash to the power 4, r upon r dash to the power 4. So r dash is what? R upon 2, r/2 to the power 4. So r cancel 2 to the power 4. So the Q is equal to 2 to the power 4 Q dash. 2 to the power 4 is 64 Q dash. 64 Q dash. So similarly, in this way, the quantity of liquid, and that is yesterday we have discussed about the flow of blood. So if there is a change in radius, then the quantity of blood flow with change of radius to the power 4. Change of radius to the power 4. This r cross is variable, that is r is vary. R vary means suppose this is the tube and here is the deposit of cholesterol deposit, then there is a change of the radius. And therefore the quantity of blood will flow, and that is all about the numericals and today part.